Okay, yeah, so welcome back to the second video. The first one stopped abruptly, but now we can go back to our PLC configuration. So let me start from the PLC configuration again. We've added our PLC hardware. We can see the rack, and now we want to configure this PLC in itself. When you click on the PLC and you click on properties, then you see quite a lot of things here. The first one is general. General is what you name the PLC, who is the author. You can add comments. For example, you can say this PLC belongs to, let me say, um, to the filling machine and conveyor. You can add whatever notes you want here. This PLC is currently on rack 0 on slot 1 of the rack 0. The rack has up till 31 slots where you can add quite a lot of things. Here you can also see the designation of the PLC. It tells you the article number. So for example, this is what you've programmed. Expectedly, this is what is in the wiring diagram, or this is what you will send to the design engineer. If the design engineer asks you, okay, what PLC are you using to program the system? This is what you would send to the wiring diagram guy, to the design engineer. And this is what he will include in the design. This is also the firmware version we chose, firmware version 2.9. There are different versions. You can have 2.8, 2.7, whatever. You can also add many other information as you wish. Now, we go into the Profinet interface, X1. There are two Profinet interfaces here, X1, X2, right? So this is X1. We give it a name. Here I've named it PN interface 1, just to make it short. And then you can add a subnet, but we can also discuss all of this later. Now, the PN interface is an Ethernet interface. You need to use IP protocol to communicate, to connect to this. So you need to give it an address. In this case, this is the standard IP address format that you input to connect. So the Profinet interface 1 actually has two slots. This one, if I click on it directly, it shows this. And you can just click on this and go to the Ethernet addresses and configure it. But I want to show it from the PLC view itself. So that's why I'm doing it from here. So if you go to Profinet interface X1, we've given it a name. Now we want to give it an IP address. Before now, 0 existed here. 192.168.0.100. This can be any number, right? It can be any number. It just depends on the number your IT team or the number that the project requires you to use. You need to actually understand all of this because there's actually some knowledge needed in this as well. But don't take it too seriously. Usually someone provides you with this, or the default is usually good. I'm changing this to 1 just for training purposes so that we know we are on the PN interface 1. And then I'm changing the Profinet interface 2 to 192.168 to 100, just so that we know we are on the interface 2. It is on the third part of the IP that the differences need to start from. For example, I have given this 192.168.1. If I go to the Profinet interface 2 and I also give it 192.168.1, you'll see that there will be some error. And it says this IP address is in the same subnet as interface PN interface 1. They cannot be on the same subnet because the main idea is for you to use this to separate them, to separate the internal connection. So the PLC tells you there is a problem. You have put them on the same subnet. You can use Anything other than one here. I can use 3, it works. I can use 4, it works. I can use 250. I can use that's 150. I can use 250. I think it goes up to 254. Yes. If I use 255, it works. If I use 600, okay, that doesn't work. So 256. So it's ends as 255. You understand? It works. So let's go back. What we want to use here is 2. Again, this is just for training purposes so that we know that we are on the second port. So again, we have our PN1 192.168.1.100, the subnet mask 255.255.255.0. Just leave this the way it is. Just accept it. This is another training on its own. The Profinet interface 2 is on 192.168.2.100, 255.255.255.0. Leave it this way. And then you can leave every other settings the way they are. What you really want to set are those IP addresses. On the startup, you leave it the way it is, standard. The cycle, maximum cycle time, just leave it the way it is again. Communication load, leave it. System and clock memory. I enable the use of system memory byte. I will explain this later. I also enable the use of clock memory byte. I will explain this later as well. These are the internal processing from the PLC itself. The semantic memory card, I showed you in the last training that the PLC has its own physical memory card, which I showed you. It says diagnostics. Do you want aging of the semantic memory card? No, we don't. We don't want that. Maybe in some processes you do, but I have never used this. System diagnostics, leave the standard settings. PLC alarms, yes, leave it the way it is. Web server, usually, do you want to be able to manage this PLC from the web server? You can activate it if you want. Many times we do this. Many times you can leave it the way. For the purpose of this training, you don't need it. And then on the display, you know, this little HMI on this PLC is a display, which I showed you as well. And this one is what you're setting here. Time on standby. Do you want it to standby, energy saving mode, things like that? It's not really, really important. One thing that many people usually do, which I also usually do, is let me say user defined logo. So you can add your own logo to it, which means when you switch on the PLC, it would show the logo. So let's say if it works. Yeah. So this is the logo we want to use on the PLC. You can do that. Doesn't Not really compulsory, but it's just something I wanted to show you. So for example, in some organizations, you need to have a logo there. So when the HMI on the PLC is on standby mode, you just see the logo. And then multilingual support languages, leave it standard. Time of the day. Usually, you want to have your PLC set to the right time. So you have to always enable the time zone where you're operating from. There is also a time of the synchronization. In this case, it's disabled. This one is usually set by your IT team, which means your PLC synchronizes with the IT network system. They will provide you with all the server inputs you need to put here. For the purpose of this training, you also don't need this. Protection and security, we already said that, right? We set it when we were doing this configuration. OPC UA is a type of communication. So we can also change this name. So I can say training PLC OPC UA. I doubt if we would go into OPC UA, but I'm just changing this name now, just in case we do. OPC UA application name. And yeah, I also enabled OPC activated OPC UA server. We might also discuss this if necessary. But the one I also showed you earlier is the system power. So here you have 12 watts from the PLC. When we start connecting modules, you would see them here as well. Power consumption, power generation, you would see everything here. If we had added a power supply unit here, you would also see it there. You would also see it here. Maybe I'll quickly do that now. And then advanced configuration, enable host name, domain, just leave this as it is. Connection resources. So this shows you, this is the maximum connection that can connect to this PLC using any of these protocols. PG communication. PG communication is using your laptop as a programming device communication. It says maximum for currently none is configured. HMI communication 4.0 is configured. S7 communication maximum 0-0. Open user communication 0 dash. Basically, it's just showing you everything available on this PLC, how you can communicate, how you can connect to it. And then overview of addresses. So these are the input and output addresses or whatever addresses that we've programmed. For now, we don't have any input and output addresses. Any input and output devices connected to this PLC. So there is nothing to show. And then runtime licenses. Earlier, this was showing error. The system required a medium type of required license. So here you just choose what you have. And this is because you enabled OPC UA. Basically, that's all you need to do. Basically, that's all you need to do. When you do this, to be sure that everything you have is correct, then you either do a right click on this, a right click and do compile, hardware and software, you understand? Or you can also click on this icon here. So I hope you can see it. This icon beside this down arrow, it shows compile, compile. So when you click on this PLC folder, then you can click on compile and then it will compile. So compile is the system, the software will check, is everything okay? As all the configuration you have done, is it correct? It will check everything from top to bottom. It will check the consistency, it will compile, check, it's basically checking everything and telling you if you can actually use this configuration on the physical hardware. Don't forget that when you completely configure all of this, then you have to send it to the physical hardware itself. And if there are any errors, this is where you then see it. So here it shows us that compiling is finished. There are 0 errors, but there are 4 warnings. Warnings are fine. As long as there are no errors, then you're fine. If there are errors, you would not be able to download this guy, this software settings you have to a physical device when there are errors. So now let me just quickly show you 2 things before we end this session. One is I want to go to the system power supply. So here now on row 0, I want to add a power supply, right? So if you want to add something here, you come to the right here, and this is where you see hardware catalog. So this is your hardware catalog. If you click on it, it pops out. This is your hardware catalog. Let me close this one. So in your hardware catalog, you see there's a rack, right? There's a PM, power module, there's a power supply, there's a CPU, there are different types of CPUs, there are DIs, digital input, digital output, there are synchronization, there's everything you can use for this PLC, everything you can use on the software. What we want to add is a power supply module. So let me see. So you have PM and you have PS, right? So let's see what the differences are. So with a PM, you have a PM of 190 watts. Yeah. And the voltage supply is 120 to 230 volt input. It supplies modules and IO with 24 volt DC via front wall wiring. So let's say we want to add this. You can take it and drag it here, right? So if you drag this here, now let's see what that does. Now, in this case, it's on slot 0, but you see it's giving us 0.00. And why? Why is this? Because it says it supplies 24 volt via the front wiring. So it's not supplying voltage to the back pane of this guy. And because it's not supplying voltage to the back pane, which I showed you before now, this PLC cannot read the voltage. It cannot read the wattage of what this guy is supplying because there is no communication between them. You can only take voltage directly connected with cable from this power module and connect it to the PLC or other devices. It tells you here already. It is connection via front wall wiring. So let's click on this and delete it. So we take it out. So it means you can also use this in the panel, but you cannot see it via the PLC because there is no communication. Now, if we go to power supply, so for example, we click on this and it already tells you it can sit anywhere. When you click on this, it tells you it can sit on slot 0, it can sit on 2, 3, 4, 5, 6, 7, blah, blah, blah. Because this one will communicate with the PLC using the back pane. So it can sit anywhere on the rack. So if we click on this and we put it here because we want our power supply to be on position 0. Now we know it says it supplies the operating voltage for S71500 from the back plane bus. So it tells you it will communicate with the PLC. The PLC will understand this guy. The PLC will be able to read it. If we now go to the PLC directly itself, I'm clicking on the PLC. Now we can see it. The PLC can see it that this guy that you've put on this rack is a 60-watt power supply. And I've added the 60 watts to my 12 watts. Now in total on this rack, we have 72 watts of power, 24 volt power supply, which means when you start adding devices now, it will start taking power out from this complete unit that we have. So you see the two different types that we have. To explain this further, let me quickly draw an image here. Let me just quickly explain what I mean here. So now, let's say this is your control panel, and this is the rack that we are talking about. So this is, you have the PLC here, the PLC itself. You have the PLC, and then, for example, you have other modules. The first power supply, which is the power module, the 24 volt power module, can sit anywhere in the panel, can also sit on slot 0. But there is no communication with the PLC because you can only take power supply, like it says, from wiring to the PLC. You can only take power supply via wiring. You cannot take power supply from the back pane. Is this clear? However, using the other guy, the power supply module, the second one, it says you can connect via the back pane. So if this is the CPU, if this is the CPU on slot 2, then you have your other modules on the line. The other power supply can sit here, 0, it can sit here, it can sit here, it can sit here, it can sit here, anywhere on the rack, because there is a communication at the back. Let me use something more clearer. So there is a connection at the back where there is communication between this power supply and the CPU. And because of that, the CPU is able to read the voltage supply, the voltage that is being read from it. And that's what adds up to our PLC, to the power consumption or power supply. If we also now go to this hardware and do a compile, it will compile everything again, check if everything is fine, and then it will tell us, okay, no errors, 4 warnings. If you want to see only the warnings, you click on this yellow. It shows you if you want to see only errors, you click on this. So I want to see only the warnings, and these are the warnings. It's saying access without user authentication, unsecure communication is permitted. The PLC does not contain a protection level. CPU does not contain any password. All of these are fine. So we usually enable everything so that when you have errors, you can show that as well. You understand? So I'll delete this now because we don't need it for this training. It was just to give you an explanation. So I'll compile this. So we'll compile this. Everything is fine. I'll save. And now I would want you to then do a project and then you can archive. So when you archive it, you are able to easily send it to someone else because this is what you will do later with the assignment that I'm going to give to you. So when you do save, then you can archive it. You can tell it where to archive, whatever, blah, blah, blah. Archive as a compressed file. You can say, okay, archive, archive. And then it comes out like a small zip file, which you can send easily. Then I can go into project. I can import it. I can open it. I can do whatever I want with it. You understand? So now let me close this project. I've saved it. I have archived it. Now I'm closing it. So if I wanted to open your project, I'll go to project and then I'll go to open your project that you sent to me. So now let's go back to what I want you to do. So this is what I want you to do. Using this link, which is on PLC wiring diagram link, I want you to look at this wiring diagram. I want you to configure this hardware configuration. So we have 1, 2, 3, 4, 5, 6. We have 6 modules in here. I want you to configure it. Whatever you can do, whatever. Now, this is an S7300 and it's a 3152DP. You need to check if you're able to read this, guys. If not, fine. I will also check it and give you the right code you should use. And then you configure this hardware, archive it, and send it to me. So do we have any questions? Do we have any questions?
No, sir, from my end. No, sir.
Okay. Thank you very much for attending today's session.